Hi, my name is Niall Sheridan, and I work on Intercom's production systems team in Dublin, Ireland, and just thank you all for coming here. So I've been working on Intercom for a couple of years, and before that I was an SRE at Google for about a decade, and then before that I worked at some small Irish companies that you've never heard of. But today I'm going to talk about how at Intercom we changed the way we manage production SSH access, making it more secure, and also without adding friction or bottlenecks for engineers. So in October 2015, NIST published this amazing report titled Security of Interactive and Automated Access Management Using Secure Shell. And this is my favorite quote of the entire paper. And many organizations don't even know how many SSH keys they have. They've configured to grant access to their information systems or who has copies of those keys. And the report goes on to identify many of the risks related to poorly managing your SSH environments, such as employees who have left your organization, or old keys accumulating long after they should have been removed, or a complete lack of key rotation. If you've ever used SSH, you should read this paper. So how did we get here? About 20 years ago, SSH was developed and became freely available. And we replaced standard tools like FTP and Telnet with it. And unlike these old tools, it supported public key cryptography in addition to crappy old passwords. And collectively, we all decided that passwords were bad and that keys were good. Keys have some nice properties. They're harder to man in the middle, and they're better for things like automating secure access. But they're also just files. So they're essentially a password stored as a file, which means that they're very easy to copy around. And managing these keys is something we collectively did not get very good at over the years, and we never progressed much further than just adding public keys to all the machines we manage. And at many organizations, these keys are managed in an extremely ad hoc manner. So I would not be surprised if many of you here share extremely privileged SSH access using a single key across a team of people for no good reason other than it's just easier. And it's really important that these keys are managed correctly, because losing control of a key can be absolutely catastrophic, potentially allowing attackers unmitigated access to production servers and data, and in some instances, this can be a company-ending event. And it sounds kind of crazy, but companies often have better policies around password management than they do for SSH key management. So account passwords tend to be centrally managed, and they tend to be administrator enforced with password requirements, such as expiration, or that they be changed frequently, or that they have some level of complexity. And in addition, we often mandate two-factor authentication. Keys don't have any of these properties out of the box. SSH cannot tell if the key it just authenticated had a passphrase ever attached to it. It cannot tell if the key was generated 5 years ago, or 5 minutes ago, or 10 years ago, or is a weak. It can tell now if it's a weak cipher, but for a long time it could not do that. And then there's your people, who are your weakest link, who are the weakest link in your security chain. People are really careless, and sensitive data like passwords and private keys get checked into source control all the time. Now, I remember a couple of years ago when GitHub launched this new search feature, which made their search infinitely better, and you could immediately find every single SSH key that had ever been checked in immediately. It was the best day ever. And finding these keys is really, really easy, and many of the deleted keys that you may find may not even be revoked. They may still be in actual use. So keys are high-value targets for theft. When Sony was hacked a couple of years ago, the hackers released lists of all the files that they stole from Sony, and many of the file names were actually names of private key files. Keeping private keys secure is absolutely critical, and the longer a key remains in service, the more likely it is to become compromised. There are several high-profile reports of stolen SSH keys over the past few years, and these are just a couple, like the FreeBSD break-in from 2012, and this one from just a couple of months back. And we've also recently learned that the CIA have written and deployed malware that has the express purpose of stealing SSH keys. All right. So when it comes to managing SSH keys, there are two sides we actually care about. There's the server side and the client side. And the server side is reasonably easy. We want new keys added fast, we want old keys removed fast, and we want it done everywhere. And we want it fast, like really fast. The client side is much more gnarly because we have very little control over it. Usually an employee will get SSH access to your production environment by providing you with a public key. And you have no say in how that key was generated quite often. You hope that the employee generated a brand new key pair just for this case. And you hope that the key is not weak. And you hope that they set a strong passphrase. You hope that their private key won't be copied to multiple machines. You hope it won't be checked into GitHub. You hope it won't be stored in backups. You hope it won't be stored on USB keys or on their phone or copied into Dropbox. And quite frankly, this is enough to make you lose sleep at night. So at Intercom, we were not happy about how we were managing our SSH keys. To give you some background, we use cloud infrastructure for everything. And for the most part, our machines are immutable. That is, we replace instances rather than upgrading them in place or making any changes. Once it goes into production, it's done. Machines come into service when we need capacity, and then when they're no longer needed, we terminate them. Our authorized keys files were once just another part of this immutable image that we shipped everywhere. So the source of truth for these public keys was an engineer's GitHub profile. And if you were in our GitHub organization, and if you were on the right team, and you built an image at the right time, you would get an immutable authorized keys file, and everybody in that authorized keys file could access our production machines. When a person joined or left the company or updated their keys, we would simply build a new image and then deploy it everywhere, replacing all of our machines. On the other hand, we do have a Bastion, which does require an SSH key and two-factor to get in, so it's not just having a private key is enough, but yeah. So for a long time, this is okay, but it became very painful as the number of employees increased and the number of our machines that we were managing increased. Having to deploy new images just for SSH keys was not sustainable. So as a workaround, we built some tools which would keep things in sync continuously with the keys in GitHub and did away with replacing machines. So they're no longer immutable, which is not ideal. So this is better, but not great. And it ensured that keys would be added and removed reasonably quickly with no intervention. But it didn't provide any additional assurances around private key security. So we were also using a third party for this. And there were some limitations of using this third party. We could not pick and choose which account public keys were baked into our image. It was all of them. We were using GitHub for this, and GitHub is under absolutely no obligation to provide us with reliable key synchronization. And we also didn't measure how quickly we could revoke access, and we had no SLO for it. So we could have quickly terminated access at the Bastion, but the time to remove all traces of a given key from our infrastructure could have taken minutes to hours, and we don't know. So we thought about the system we would actually want to build here. At a high level, we want to enable engineers to do their jobs without too much friction, so they can get access to resources they need using their standard tools, and workflows largely remain the same. We want the things I discussed earlier on, like we want keys added and removed quickly as possible and reliably. We want regular key expiration, and we want an audit log so we can see when keys were issued and when keys were used. And ideally, we wouldn't have to build the entire thing from scratch. And that's where SSH certificates come in. SSH certificates were added about 7 years ago to OpenSSH. They're not new. And the way they work is that you use a signing key to sign other private keys. And despite being around for so long, certificates have mostly been ignored until fairly recently. They're not X509 certificates. They don't have the properties of X509. You can't have like chaining signatures or anything like that. But they're not a new format either. They're essentially an extension to the existing SSH key implementation, and the signing key is just another private SSH key. And because certificates are signed by a central key, the only thing you need to distribute to all of your instances is the certificate authority's public key. So when you SSH using a certificate, the server will check the signature of your certificate, and if it trusts it, then it will automatically just let you in. And what makes certificates really attractive is that you can set additional properties inside the certificate. So this is the structure of a cert, and there's a lot in here, but we only care about a little bit. So there's two types of certificates. There's the user cert and the host cert. Right now, we only really care about user certificates, but it is worth mentioning that you can sign host keys as well, and you can configure your SSH client to trust the host key. So when you add a new machine and put it into service, and the first time you SSH into it, it says, hey, do you trust this machine you're logging into? That's no longer a concern because your client will trust the host key so long as it's been signed by CA that your client trusts. It's all automatic. The key ID is just an identifier. It's just an identifier for a certificate, and this is what gets logged when somebody logs in using a certificate. And this can be whatever you want. And this is my favorite of all the settings because you can configure a lifetime. You can define the lifetime for which the cert is valid, and the server will reject the certificate if it is used outside of this period. This won't terminate existing sessions. This will only disallow or allow sessions on authentication. Certificates can also have principals. They can be multiple principals. And that allows you to restrict a certificate to a named set of users. So even though SSH will trust any valid certificate signed by a given CA, the certificate will only allow access to a specific user, either because it's explicitly named in the certificate, like here, or because you've configured an authorized principals file to map one principal on the certificate to a username on the server. So if you used shared users on the server, this is extremely useful. In comparison to keys, the only association that a key has with a specific user is whether or not it is in the authorized keys file. You can also restrict what a user can actually do with their valid certificate. For example, if you want to limit user access from a specific set of IP addresses, or so they can only run a certain command, you can hard code this into the cert. If you want to allow or deny permissions like port forwarding or agent forwarding, you can also bake that in at creation time. So enabling certificates requires some changes, but it's actually incredibly straightforward. All you have to do is use a version of OpenSSH that is newer than 7 years old. Yeah, that's actually it. On servers, you need to add the trusted user CA keys file, and you need to keep all of the CA public keys that your server trusts. And you can put multiple. You can generate multiple CAs in advance, and you can populate this file with like 8 or 10. I think in Intercom we keep about 5. And this allows us to retire a CA key and start using a new one that we've just pulled out of a safe. And we can do it without having to update all of our infrastructure in lockstep. Yeah, I don't think of anything else to say about here. Yeah, the authorized principals file, you can just generate this file. Like we use this. We log into a lot of our machines as like the EC2 user account, and we can use this authorized principals file to say, on these machines, this name set of users can authenticate as EC2 user, and on these machines, this name set of users can log into the shared account. So even though it's a shared username across multiple machines, we can still filter out access based on whether or not a person should have access to that account. All right. So by using SSH certificates, we've reduced the number of keys to be managed to exactly 1, and that's the signing key. And the signing key is entirely under our administration and not user control. And this solves a lot of our key management concerns, but engineers still need to be able to get these certificates so they can access machines in order to do their jobs. And so to reduce friction, we want to make this entirely self-service if we can. So most of the apps we use, because we're a very small startup company that doesn't have things like LDAP and Kerberos and other things that a lot of you might take for granted, we use Google Apps or Google G Suite for an awful lot of our source of truth for users. So if we could reuse this for authentication and authorization, this would be ideal. So we built a certificate authority which authenticates users against Google OAuth, and it allows users to exchange their OAuth access token for a valid SSH certificate. And we named the CA cashier. And this is how it works. I'm not going to live demo this. So it works like this. The CA is just a web service which authenticates users via Google OAuth. So the user opens up a terminal and runs a command, and that pops open a browser window, and it redirects them to Google to log in. They log in to Google as normal, and they get redirected back to the CA where they're given a token. And they copy the token, and they paste it into the terminal where the cashier client is running. At this point, a new SSH key pair is generated in memory, and the public key is sent to CA along with the just pasted token. The server, the CA, will check that the token is valid, and if it is, it will sign the public key and return a valid certificate. And the cashier client will then store the private key and the signed certificate in the SSH agent, and the user can SSH everywhere as needed. And so keys are generated entirely in memory, and they're stored only in the SSH agent. Nothing is written to disk. The only part of the key that leaves the client is the public key when it's sent for signing. And so if a client machine gets restarted, or if the SSH agent process dies, then the keys are lost. We record every issued certificate. If we need to, we can revoke individual certificates. Cashier will generate and serve a revocation list, and our machines will periodically update their revocation list, but usually we avoid this entirely by issuing certificates that are quite short in terms of validity. So if we have to, we can expire a key, but the certificates we generate are only 20 hours long, and so if a person, if it is easier to just let the key expire naturally, then we will let the key expire naturally. So with certificates, we also get somewhat better logs. We used to only see the SSH key fingerprint, which does not exactly tell you who is logging in. But with certificates, we actually get the ID that is baked into the certificate. And so we can actually see who is logging in and when and where and using what key. And so we can use that for revocation purposes. So this drastically changed how engineers get SSH access. But aside from some minor config changes, the tools and workflows that they used continue to work as before. The biggest and most important difference now is that user certificates expire, and they need to be periodically renewed. But this only takes seconds, and once issued, there's no wait time for keys to synchronize to production. And this is really powerful, because when it's really cheap and really easy to get on-demand access, you can set really short lifetimes for keys. And instead of having like months or years, you can have weeks or days or even hours. And another thing we've noticed since doing this is that people typically will not generate a certificate until they need it. And so previously we could have had like hundreds of SSH keys roaming with access to our production infrastructure. I checked earlier on, there's like 30, because people only generate them as needed. And if we need to, we can revoke any of those 30 keys anytime, and the process for generating new keys is extremely low friction. On production side, we've stopped syncing keys from GitHub onto machines, and instead we've just added the CA signing key to all of our machines. We can now easily identify who is accessing production using what key, and if necessary, we can revoke access quickly and easily. And that is how we stopped managing SSH keys at Intercom. The source is freely available there, and if you have any questions, with this time, I will try to answer them.
If you have questions, please come up to the microphone for the benefit of the recording.
Hi, so great work. It's good to see more improvements on SSH security. I'm curious, what's your roadmap with Cashier?
The roadmap is, right now this does more or less everything we need out of the box. What we'd like to do is make it do host key signing as well, so that we can automatically generate a valid host certificate for new machines we bring into production. Other than that, revoking entire CAs easily and quickly is also on the roadmap. That's it, really.
Okay.
Is there anything particular that you would like?
Well, well, actually, so I'm from Somatic, but formerly I was also at Google, so I'm familiar with prod access. Mm-hmm. And
I'm reassuringly familiar.
I see. Yes, I see the fingerprints there. So we've been working on a tool called Keymaster, and it actually does ephemeral SSH certs. It was X509 and Kerberos SSL certs as well. But also we have two-factor U2F and Semantics VIP access built into that as well. So we actually have a 2FA production of credentials. And we have both like a client, which it doesn't require the user to actually copy and paste from a web page. It's just the client directly calls out to the keymaster, gets his credentials, and all you do is type in your password and touch your second factor.
Yeah, that is desirable.
So I'm kind of wondering if you're planning on heading in that direction, or if you want to collaborate.
Certainly interested in chatting.
Use ours.
One of the things that we'd like to do is like what's currently on top of my mind for our production environment is minimizing say use of API keys. And I would love if we could actually like have a broker that would give ephemeral API keys, because we're a SaaS company and we literally use a million other companies to get things done. So we put everything in AWS, and we put our metrics in Datadog, and we put other metrics in Honeycomb, we put logs in different place. If we could, instead of issuing API keys and then storing those keys locally, if we could ephemerally create a valid API key for a broker that would do the right thing.
So we actually have an AWS broker as well, because we've like a year and a half, 2 years ago, we started moving over to public cloud. We've done a lot of work in that area as well.
Interesting.
So yes, we should talk, and anybody else should come find us. Camilo there is the guy actually did most of the implementation on this, by the way. So yes, and our project's also open source, so it's not a product you have to pay for. No licensing.
We should chat.
This is kind of a twin question. So the first half is how fast do your app instances refresh their CRLs? And the second half of it is how hard is Cashier as a service to run, considering that update interval? Because they're kind of a funny trade-off.
Okay. So our KRLs refresh within 5 minutes. So I think it's 4 minutes to 5 minutes plus jitter. So we give it like 4 or 5 minutes plus jitter, so we're not like everybody is syncing everywhere from one service at the same time. In terms of how hard it is to run, we run it in a separate AWS account so that regular users in our production AWS account can't access the thing that can sign all the keys. And we run it on, I think, a small EC2 instance with an ELB in front of it, and it loads the private SSH key from KMS. It's very simple. But it's not AWS specific. This can run on a server. Like in my house, I run this on a Raspberry Pi, so I can SSH into my own VMs that I run elsewhere, and yeah, it's no effort. Right, thank you.
So he actually addressed part of my question, but the rest. Is there any sort of thing of passphrases, or is that just totally inapplicable? Do the certs all get generated at the central point, so you control how they're generated, or?
When you say passphrases, you mean?
Well, you covered earlier in the talk with keys how right. you can't enforce whether or not a passphrase was, whether or not the key that was generated has a passphrase or not.
That's true.
And with a cert, I don't.
Yeah, so the cert does not have a passphrase, and what happens is when the certificate is added to your SSH agent, you essentially have the same problem that if you add a passphrase to SSH key to your SSH agent, and that you've unlocked it and it's now available inside of your SSH agent, and the controls around your SSH agent are the same. Because we issue certs with a very limited lifetime, we don't add passphrases onto them. We just assume that it's only going to last for less than a day.
But I think I got in what you just said that it's possible to do with passphrases also?
I don't know. I've not checked.
Okay. And then my other question, which you only sort of addressed, was you said you could revoke any of those certificates at any time. But my understanding may be incomplete on how the signing architecture works. I would expect that generally speaking, when you issue a new certificate, it doesn't require any interaction with your production environment because they already have the public key of your certificate authority. They can check the signature. When you revoke a key, when you revoke a certificate, what has to happen for that revocation to actually take effect across production?
So what has to happen is that on our side, we check a box and click revoke, and that updates a field in the audit database. And then Cashier has a URL endpoint which serves a binary key revocation list. And all of our servers just pull that down and put it into place.
Is that part of every authentication, or is that periodic, or?
It's periodic. We use it as a cron job.
Okay, cool. Thank you.
Hi. At what level exactly in the stage of generating certificates you specify the principles and the extensions needed for that certificate?
That's a good question. The way we do it is that the CA will automatically infer the username based on what is used for authentication. So if you are Niall at intercom.io and you sign in, it will write in the principles file, or in the principle for the certificate Niall. But you can also specify additional principles on the server side, which will be baked into every certificate. So if you want to put the username Ubuntu in there, you can just hard code it in. But for the most part, the way we expect this to work is that you have one certificate, it's your name, and then you control the server-side login using the authorized principles file.
Okay, thanks.
Sure.
So how does Cashier interact with the lifecycle of the SSH agent? Because there are some SSH agents like GPG agent which will actually persist the key to disk if something adds them, and do you have anything to prevent that?
So the good news, and it's not really great news, is that GPG agent does not understand certificates at all.
Oh. Well, that's a bug.
Yeah, it's a bug, and they have no plans to address it. It's bitten a couple of people who work for Intercom. For the most part, we just use the out-of-the-box SSH agent because that's the reference implementation.
Okay.
Right. Oh, I'm sorry. We don't recommend use of things like GPG agent because despite the fact GPG agent has SSH agent support, it does not support certificates at all. Okay.
So you explained you're not killing sessions after the certificate has expired, but if you have a revocation, you might want to kill the sessions. Do you have any solution for that?
The current solution is to restart the Bastion servers, which will kill all sessions automatically. We don't have any automated hunting and killing of SSH sessions yet.
All right. Everyone, round of applause for Niall. Thank you very much for your talk.